Welcome to my channel. Today's topic to discuss is about encapsulation. It allows us to encapsulate data and methods within a class, providing a shield of protection and controlling access to the inner workings of our code. So, what exactly is encapsulation? Well, think of it as the art of hiding complexity and exposing only what's necessary. It's like a protective barrier that prevents direct access to the internal implementation details of a class. In C++, we achieve this by using access specifiers, public, private, and protected. To illustrate the power of encapsulation, let's consider a simple example. Suppose we want to create a bank account class. We'll start by defining our class with private member variables, such as account number, balance, and owner's name. We'll also include public member functions like deposit, withdraw, and get balance. C++ provides mechanisms to implement encapsulation, namely, access specifiers and getters, setters. Access specifiers, such as public, private, and protected, define the visibility of class members. Let's see how each of these specifiers works. Public members are accessible from anywhere and can be used by any part of the program.
In the above example, we have a class called circle that represents a geometric circle. The radius member variable is declared as public, which means it can be accessed from outside the class. In the main function, we create an instance of the circle class called myCircle. Since radius is public, we can directly access and modify its value using the dot operator. We then call the calculateArea method on myCircle to calculate the area of the circle.
Private members are hidden from the outside world and can only be accessed by other members of the same class.
In the above example, we define a bank account class that represents a bank account with private data members' account number and balance. These private members cannot be accessed directly from outside the class. Inside the bank account class, we provide public member functions like deposit, withdraw, and display balance to interact with the private members. These functions allow controlled access to the private data and ensure that the account balance is modified or displayed in a controlled manner. In the main function, we create an instance of the bank account class called myAccount. We can call the public member functions like deposit, withdraw and display balance on myAccount to interact with the private data members indirectly. If we attempt to access the private member's account number and balance directly from outside the class, the compiler will generate an error indicating that those members are private and cannot be accessed.
Protected members strike a balance by allowing access to derived classes.
In this example, we have a base class called vehicle that has a protected member variable max speed. The protected access specifier allows derived classes to access the member variable, but it remains inaccessible to objects of the base class or outside the class hierarchy. That concludes our discussion on encapsulation. If you have any questions, ask in comments. Thanks for watching and subscribe the channel.